Hey everybody, this is Larry, this is Miko for Q4 of the bi-weekly contest 63. Cave smallest product of 2 sorted away. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this problem. So this one, it was very hard for me. So yeah, also join me on Discord if you want to talk about this one and other problems and contest problems. There are more and more smart people there now, not including me, hopefully. Come chat and hang out, especially if you like Leetcode contest. Anyway, yeah, Cave's smallest product of 2 sorted away. So this one was a very hard problem, though a good amount of people did end up getting it at the very end. I took a long time because I ran into a lot of issues, and just for kind of learning purposes, I'll go over those issues later. But I will go over my algorithm, and the algorithm is basically a binary search. But just saying that is easy. Just saying that is easy, but actually doing it was the hard part for this one, for implementation, because I think I got the algorithm, I don't know, maybe in 10 minutes, which is probably slow because I couldn't fit. Well, I spent a good amount of time proving myself, but yes, I got the algorithm relatively quickly, but I spent a long time, like half an hour, just writing it out and debugging it and breaking into different cases. Actually, let me take a maybe I will take a look later of other people's solution. Maybe there's a cleaner way of doing it, but yeah. So basically this one is just binary search on the answer, but that even then is a little bit tricky. So what do you do with that? I mean, the short answer is that this is a general way to get the cave smallest something, right? Maybe not in this case for smallest product, but for example, you have some number. You have a series 1, 2, I don't know, whatever, 3, 4, 5, 6, 7, 8. I'm a little bit lazy. To get the cave smallest number, you do a binary search on this result, right? And then the idea is that you convert this into a true false array, and this can mean anything, if you will, where your true false answer question, if you will, is actually are there k numbers smaller than target, for some target that we're binary search on, right? So this is the answer. And then, for example, what does that mean in this context, right? That means that, for example, we have this array. Let's just say target is equal to 6. Then it becomes, false, 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 false. Sorry. In this case, this is true, 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 true. And in this, I forgot to put the k. Oops. So k is equal to, I messed it up. Sorry, friends. Let's just say k is equal to 6. Then in this case, this array will look like something like this, where everything is true, and then everything here is false, right? No, I messed up again. Sorry, friends. Yeah, so this is all false. There are only 5 numbers, and then it becomes true, right? Because there are more than k numbers smaller than target, right? So if target is 6, then the answer is true, and so forth. If the target is 9, then the answer is true, and you can pick any number, and this is the binary searchable array. So basically, you convert. And then you do a binary search on this implicit domain instead, right? Or bisection, some people might call it. But yeah, so then now you have this false true thing, and then you in this case, you're trying to get the first true. Okay, so then now we have this thing. I actually had a lot of issues with this one, but that's basically the first concept, and that concept I think comes up from time to time, and you might have recognized this, but doing this is not enough. By itself, it is not. It is not enough. By itself is not enough. You have to know how to figure, because in this case, you have to get the smallest product, and that's where I kind of book everything into cases. So basically, in this case, let's actually use a real example here. Let's just say this one, right? In this case, I literally broke it up to, for each array here, I broke it up into 3 components. You don't have to do this, I think, because there are people who probably did not have to do this, but I did it this way, and it's just, I think it's easier to kind of reason it out, because the reason why I did this is because I knew that if I make a mistake, most of the core concept is going to be correct. So therefore, I'm just probably doing off by one, so I could grind it out. That's my logic. I don't know if it's right, but that you can take your word for it. But basically, I split into 3 components where, for example, for here, I split into positive numbers, zeros, and negative numbers. So in this case, positive would be 3, negative would be just 1, 0. I mean, I actually represent this with a number, but you get the idea. Oops, this is 0. And negative is -4, -2, right? Yeah, and then let's just say we do the same thing for the here. Let's actually use this one instead. Right, so now we split it into positive and negative numbers, right? And if maybe hopefully you already kind of get the idea of what I'm going for, because here then now we just break it down into different components again. So basically, if yeah, so we go through each, and you could take one of them. Maybe that's why I have a maybe. No, this is why I have a maybe swap here. But basically, for each number here, we can figure it out from these components. For example, let's just say target is equal to 10, which is positive. Then what does that mean, right? That means that, and this is what I did literally by breaking it up in pieces. That means that, okay, if target is equal to 10, then all the negative products will be smaller. And how many negative products are there? Well, the negative products will be the positive 1 times the negative number. So these are all in there. So you have, so that's the number of say. So this is a cross product review, not a cross product, just I guess it's a cross product without the sum. But yeah, so all this stuff, you have the positive numbers times the negative numbers, so that makes sense as well, right? Hopefully, because these are all the negative numbers. You have to count the zeros, so 0, in this case, 0 of 1 times all the numbers in nums2, so 0, 1 times nums2, and then of course, in this case, it's an apply, but I'm going to add a random 0 just for illustration. Then 0, this one, times all the other ones here except for other zeros, right? So you can write this in a number of ways, but you can write 02 times nums1 minus 01 or something like that. You can write a number of ways. I actually wrote it another way during the contest, but that's basically all the yeah, so let's divide the answer into, okay, so these are negative numbers that are clearly smaller than the target. You have zeros, which is also clearly smaller than the target, and then you have and then now you have numbers, and then now you have positive numbers, right? So positive numbers is going to be the tricky part, for at least for this target, because in this case, what happens is now we try to figure out how each one works. And here we only look at the two. Well, if you break down the possible numbers, then you have +1 times +2 and -1 times -2, right? Because then now they make positive products. And then all I do now is do a for loop. That's the trick answer. So I have 3. I could do a binary search on this one to kind of get the number of, and you actually don't need to do a binary search, but that's the way that I did it. But yeah, you only need to do it with one binary. So I did it with binary search during the contest because I thought it would be fast enough. But if it wasn't, then I would have did a 2 fingers algorithm, because as you go from left to right and you keep these sorted, you can go from right to left on +2. Hopefully that makes sense. I'm going a little bit not that fast. But yeah, but the idea is that, okay, let's say you have 3, then, and I don't know, target is 10, then that means that the 2 is the answer, because 2 is, you do a binary search on dividing or whatever, but you know that there's going to be one number that is going to be that matches with 3. But for example, if you added 4 and 5 here, then the 4 also matches with the 2. Okay, maybe we add a 1 here just for illustration. But if we had the 1, then the entire thing matches because 1 times 5 is going to be less than 10, for example, and so forth. And then we basically, for each number in parse 1, we do this check, and then we just sum it all up. And you can do this in linear time. I did it again with n log n by doing a binary search on each one, but you actually did not need to. Yeah. Yeah. And then, of course, you do it the other way as well with the negative numbers. Being careful to handle the negative numbers because, well, for a positive target, I guess it's okay. But yeah, basically you do the same thing, but you have to be careful handling it. But, you know, -4 times -3 will be 12, but -2 times -3 will be +6. I don't know if I said the right thing before. Yeah, but either way, you get the idea behind this thing. So basically, that's all there is for this problem. Double binary search is how I did it. You could actually do it with only one binary search. But I'll go over my code, and then we'll probably go over one of these other code, and maybe there's even fewer test cases actually now that, or edge cases. There are fewer edge cases if you do the 2 pointers, I believe, but that's not what I did. So yeah, basically here is the binary search. The reason why I broke it down is because I don't know. Maybe you don't need to break it down, but the reason why I broke it down was because I couldn't handle the Leetcode case correctly. For negative numbers. So basically I did a thing where I binary search to see if it's positive. If it's a negative number, I do a binary search under negative. So I don't know. I don't know if this is needed. Probably not. You could rewrite this in a better way. But during the contest, I couldn't figure it out in time or in a good amount of time. So I was like, actually, let me just do it this way. Maybe it'll be good enough. And anyway, it'll be 2 different cases. Maybe they have like weird rounding situations. So that's why I have it here. And of course, this is going to be O of log U, where U is the size of the domain, where for me, it's just 10 to the 10. I add a random number just to kind of go whatever, but that's the idea. And then here is, okay, given a certain target, I think we said that actually, I erased it. Okay. Given a target, how many products are smaller or equal to target? So yeah, and I book in the 2 pieces in here as well. So if target is greater than 0 or equal to 0, we do these things where we count the number of zeros, and then we also do a binary search. Or sorry, for each number we do a binary search. And this is positive matching with positive, negative matching with negative. Keep in mind that I actually in my negative array, I actually used the absolute number, and I parsed this here. So yeah, so keep that in mind about your binary search, and that's why I can do it, you know, in this way. You may not have noticed if you don't pay attention, or because I skipped it over too quickly. If the target is negative, then we actually match. Well, if it's negative, then we don't count the zeros, so we just got rid of it. But otherwise, we do a binary search to get you know, you just have to think it through, but basically you get the parts that are bigger than that part instead, because then you get a smaller negative number. Again, you can also use 2 pointers. This is also going to be, given a target, this is going to be O of n log m, and this is why I had to maybe swap here, because if n is way bigger than m, swap up so you get O of m log n, but that's a small optimization that I didn't even need. But yeah, and so basically you call this O of log u time, so this is going to be O of n log m log u, right? Time complexity, space is just O of n, I believe. Because we kind of rewrite the formula. You in theory you probably don't have to, but that's the way that I did it. But yeah, in this case, like I said, this is O of log m. This can be reduced to O of n plus m by doing a 2 pointers algorithm, as I mentioned, with two fingers or two pointers algorithm, and in this case, it is just going to be O of n plus m log u time with the two pointers algorithm. Yeah, let me know what you think, and same space. Let me know what you think about this problem. I'm going to stop here for the parsing code. Here's my binary search code. You can do two pointers, and I definitely actually urge you to practice doing the two pointers at one. And then the binary search. This one is a little bit yucky, but I just want to show you how it looks like. But yeah, yeah, that's all I have for this one. Let me know what you think. And you could watch me solve it live next. Long answers rough on the first two, and they're not easy, but they're not super hard. So let's see. Leetcode's already finished. Good, and a lot of people already finished even. But where am I? I'm not doing very well. A lot of penalties. Yeah. Actually, doing pretty good after two problems, but wrong answer. Okay, let's see. Cave smallest product of two sorted arrays. I feel like I've solved this one before, but maybe I'm wrong on that one actually because of negative numbers. Maybe. I feel like I have to. Cave smallest product. Okay, so they're already sorted. I feel like I've done this before, but I'm trying to think. I mean, it's definitely binary search, but I'm trying to remember how to think about it. Okay, this could be too big. I mean, you can't even do an O of K, so. And there's some stuff about positive and negative numbers, but I don't think that even matters. I think I know how to do it, but how do I code it? This is a mess to code, maybe. So I have to do log n and then log n. Okay, double binary search. Is that it? I mean, count might be a keyword, that's why. I think the problem I'm thinking of is in binary search based on one array on itself, so I think that's different, or something like that. Now that I think about it, this should be doable in an hour. I just have to be careful. Okay. Basically, X. So I have to find Y such that this is true. This is so annoying to write or think about. There's so many cases. Okay. X. I need to do that for. I guess so. Maybe that's easier. How do people do it so quickly? Map props. Each number. Yeah, now you're careful, Larry, after all the silliness. A lot of, okay, not that many people got it, but a lot of people got it. Oh, Cooney, oh, good job. Okay. So, okay. Oh, oops. Cancel one. Maybe I don't need this one, but I do need it. So 1 times okay. If it is positive, then positive 1. Which one to get? Okay. Now we want to binary search on pos 2. plus number of indexes, and they should be strictly equal. So maybe this plus 1 though. I always forget about binary search. This is okay, I think this is bisect, right? I hope my eyes a little too hard. I think negative have to be reversed. So that we sort by absolute right. Or maybe just right? I think that's right, except for I mixed this up. Okay, yeah, and then now we have to count all the things, all the negative ones, right? Otherwise this is negative. So, yeah, this is the case that I don't know about. Because smaller means now you want something that's oh, this may be wrong too, is it? No, this should be positive, should be good. Okay. Yeah. Okay, but now this is the opposite of that. Now we want the negative. So okay, we don't count the zeros, we don't do all this stuff, we just do no, not this way at least. Binary search for something that is smaller, or that means that this is, we want something that's larger. So okay, I think this is right, but I don't know if this is right. I'm gonna have so many off by ones, but that's fine maybe. Literally 10 to the 10, right? is too many, that means everyone's smaller number. Okay. I'm too lazy to think out of the case. Generator is not reversible. I didn't know that actually. Oh, that's not even. Is this even right? What am I doing here? Yeah, okay. That's a very fortunate typo actually, because I might have gotten it wrong otherwise. Okay, let's see if this is good. Not even for the positive one. I was hoping at least this one's good. Because these ones may be a little bit trickier, but okay. I think at least we have something. Not good enough though, but something is better than nothing. Something's better than nothing. It's gonna print a lot, but that's okay. So that's true. That's 4 numbers, is that right? I guess that's true. That's not true, right? So for 6, how many do we return? For 6 we return 1. Oh, I forgot. No, this is right. We want it to be 0, but it returns 1. Oh, it's one number, so we actually should return this -1 for the index. So I think this is actually one basis may be easier in this case. Okay, it's still wrong though. Unfortunate. That's fine. 9 is 2. 0 is 6. Nine returns 2. 0 is 6 is that part of this one? On the second number, so the number in which the 2 less than, so it returns 9. So 9, are the 2 numbers less than? Yes, that's true, but it cannot be good enough yet. Okay, I guess that's why. So this is, so if this is equal, then we have to do it. Wait, is equal to mid. Okay, so I think I got the first one right. The second one maybe is right. I don't know. Just lucky. Last one is just way wrong, but that's maybe expected. Yeah, I think the binary search should be right now, but the other part isn't right. So let's see. This ridiculous number, this 10 is definitely not right. So my thing is way wrong here. Target is negative. I have this big number, and oh, because target is negative, so okay. So I was treating it like I already flipped the thing. So okay, it's not quite right, but it's more closer. Did I just have an off by 1? So -6 and -7 is, so I don't think I handled the negative number off by 1s correctly, because I returned the largest target number where that is true. Wait, what? Because -7, I see. So this logic, actually the binary search is wrong, not this one, which is actually funky. I mean, this was wrong, but so basically now what we want to do is that actually, oh, that is a good one actually, because we want to get, wow, how do I even think about this one? That is definitely true, but else, if mid is negative, what do we do? If mid is positive, we set this is true, otherwise this may be infinite loop, because I don't know that I'm right. That is a hard one. I actually don't know how to do this on binary search. Okay, so oh, I just point out too much. Okay, maybe that's fair too, but that's just an infinite loop, I think. But how do I handle this delicately? Dun, dun, dun. Yeah, okay. Oh, I'm close, but I'm not handling the negative numbers right, because I'm still counting too weirdly. Okay, let's just put into different things then. Okay, so this should return -2 maybe. Okay. Maybe that's right. I don't know. And now in this case, if it's equal, so now if it's equal, that's not good. +1 maybe? Could be -1 actually, but whoops. Nope, I'm wrong. Okay, but is this right? If this is equal, then we want to left side still in the bound. Okay, that's fair maybe. Alright, let's just give it a YOLO. I mean, if it's wrong, it's wrong. Okay, that's actually a very easy one to debug, though I don't know why. It takes so long to. That's a silly case that I should have tested, though, possibly. I actually did not. Yeah, I didn't. Because all the inputs are all negative. No, that's not true actually. Don't know. Maybe I'm just wrong in some places. Where am I wrong? The answer should be -9. But here, oh, because it's 1, so it keeps on going up, up, up and away. So this is definitely wrong. I think in this case, what I want is yeah, that's not right either. I don't know how to handle the negative case. So it's basically the last true, right? Why am I so bad at this? It's wrong. This is wrong because I keep going up because it keeps on returning 1. I can't believe I'm stuck on the binary search part. I'm so bad at binary search. Should be only here, yeah. So then now this is 1. Then we actually want, because this is equal to, do I handle equal to correctly? Maybe I don't. If it's equal, then what happens? Then we want actually, shouldn't we? Why is this wrong again? Oh no, now it's infinite looping, that's why it's wrong. If it is equal, then oh jeez. Why does this infinite loop? Is that right? Oh, because in I forget that this actually doesn't do what I wanted to do. Let me verify something. I forgot that Python is silly with the negative thingies. I did actually forget that, so that's why I was. Yeah, this is -3 instead of -2, which is why. Huh. I forgot about that. How would I fix that? Let's forget. I'm thinking about too much random stuff. Oh, this is also wrong. This should be plus. That's probably why, actually. When did I change that? Why was that so bad? I wonder if now this works. No, I don't think that would work, but what is going on here? Actually curious why now this doesn't converge. -10, why? Because negative. I know this isn't right, but I just wanted to. 11. And this isn't even right anyway. Oh. Well, no, -10 is kind of right, but I need to do this locally so I could exit out this immediately when this happens. How does that happen? Oh. I don't know how to do binary search, maybe. Especially when it comes to negative numbers of weird division. Huh, never had to deal with this before. Alright, let me double check that my logic is right at least. Okay, so if they're equal, then actually we want the right to be met. Right, yeah. Why? Tell me why? Was -12. left, right, mid is 11. Negative 12. What is the answer of negative 12? Also 1. Oh no, it's C. Well, that's not right. Can't believe I'm spending so much time on oh yeah, negative 12 is 0. But why? That's not true either. Or at least negative 11. Actually, yeah, I think I'm just wrong on my other binary search. Negative 11 should not be 1. That is the issue, maybe. Okay, so maybe I just have issue elsewhere. Okay, so it's here. In the negative. Okay. So what am I saying here? For every positive. So this is 3 binary search. Negative 2. So this would try to put all the numbers down. So this would try to put this at 0. Did I mess it up? So we want. So for negative 12. So for 12, we search for 4. Basically, what we want is what do we want? So for 12, this number is going to be a 3. We search for a 4. There's no 4, so this returns 0. Oh, Well, no, that should return 1. So this should return 0 for negative 11. Oh no, because this is bisect left because of negative division thingies. Maybe? I don't know if I'm actually right on that one, to be honest. I think maybe I'm just making it up. But it is right on here. Let me think about it for another minute. Why does this work? Because we want all the numbers that are bigger than and smaller. Okay, maybe. Let's just give it a submit. Probably wrong, but we'll see what the test case is. Did I get rid of all the print statements? I got rid of the print statements. Okay. Oof. Maybe this is not my day of solving anything. Expected 32. Output 64. That's not even off by 1. How did that happen? So on the positive side, so 880, what are we looking for? 73. I think I'm just wrong on some numbers here. Oh, I forget zeros on part 2. Whoops. Huh. Okay. Whoops. Whoopsie daisies. that's it. I mean, if that's it, that's a easy fix. I mean, I just fixed it, so it's just dumb. But let's try again. I should have tried the other inputs. Okay, well, okay. I mean, that wasn't bad, but I was very sloppy and not very good at this one. Yeah, thanks for watching. Let me know what you think. Hit the like button, hit the subscribe button, join me on Discord, especially if you like these contest forums. A lot of better than me people are there as well now, so we can all chat and kind of complain about Leetcode or just brag about your whatever. I don't know. Anyway, stay good, stay healthy, to good mental health, and I hope y'all have a great rest of the weekend, and see you next contest. Bye bye.